Hey everybody, it's Mr. N, and this is a review video for some derivatives and integrals that are a little bit more difficult. So let's go ahead and get started. On this first one, it says y equals natural log to the fourth power of x, and we are to take the derivative of this. So let's do this. So this can be thought of as the natural log x to the fourth power. So y prime would end up being 4 ln x to the third power times, now I chain rule this part, and the derivative of natural log of x is 1 over x. Simply cleaning this up, I get 4 ln x, you could go like this, over x. Or if you could just leave the ln x to the third power in parentheses like this, which is just fine. Okay, on the next one, here we go. Same concept over here, though. We need f prime of x, and I'm going to go ahead and I'm going to need to use a quotient rule here. So I'll take the bottom, 2 ln x times the derivative of the top, which is 3x squared, minus the top, x cubed, times the derivative of the bottom. Derivative of the bottom is going to be 2 over x. All over this 2 ln x squared. Why is the derivative of the bottom that? Because derivative of this, 2 is a constant, derivative of 1 ln x is 1 over x. All right, so now it's just a matter of cleaning this up. So this will reduce with one of those to make it a 2, which would give me 6x squared ln x minus 2x squared over the bottom, which would be 4 ln squared x. You could reduce this one step further to end up with 3x squared ln x minus 1 all over 2 ln squared x. All right, moving on to the next one here. And we've got this. Remember, the derivative of a to the x is a to the x ln a. So taking this derivative, y prime, I would end up with 2 to the negative 4x times ln 2 times, now I have to chain rule this, negative 4. So cleaning this up, y prime would just simply be negative 4 ln 2 times 2 to the negative 4x. You could leave it like that. That didn't look so good. That's an x right there. Let's try that again. And there is that answer. So for the next one, this is the inverse sine, and our formula for the arc sine for the derivative is 1 minus u squared du, and this is our u right here. So f prime of x would be 1 over root 1 minus 5x squared, but now I have to do du, so in this case I have to multiply it by 5 because of the chain rule. So f prime of x would be 1 over root 1 minus 25x squared. All right, moving on to the next one over here. And this is the same thing, we just write arc sine, which is the same as doing it this way, so it's the same exact formula. So our u, in this case, will be the 3x, and we have the 2 out in front. So our derivative here, f prime of x, will just be 2 over root 1 minus 3x quantity squared times the 3 because we're chain ruling it. So f prime of x will be 6 over root 1 minus 3, or we'll say 9x squared. All right, you have to memorize this formula. You have to memorize this formula right here, which is the arc sine, that one, okay? For number 6, this is just the a to the x formula, which is a to the x ln a. Ln a. So f prime of x for this one is going to be 3 to the x minus 2 times ln 3. And now I do the chain rule, which is really just times 1 in this case. So f prime of x will be 3 to the x minus 2 times ln 3. All right, or x minus 2, yeah. All right, moving on, let's take a look at what we have on the next set of problems. Now we need to do some integrals. on this first one, I need to take a look at my integration formulas and match it up. This one will look for number 7, it will look like the integral of 1 over root a squared minus x squared dx, or you could do this as u's, and this is the arc sine, which is the ones we've just been currently doing. So take this 8 out and you'll end up with the integral of 1 over, now let's determine. Over here I have a as being 6, and then you can say u is just x. So du would just simply be dx, and then we're going to substitute it in over here, and a is 6 because it's the square root of that 36, so I'm going to get 6 squared minus x squared, and my du just says, you can put this as u squared actually, and my du is just going to be the dx, so it doesn't matter at this point. So now I know that this is the arc sine. According to the formula, I have the arc sine of u over a plus c. There's various ways of learning the formula. This is the way we did it in class, so then I just plug this in. So 8 arc sine of u, which is x, over a, which is 6, and then plus my c. All right, moving on to the next one. These can get challenging, but you got to know your formulas. So I take a look at this one. Again, the 8, I'm going to ignore it. I'm really focusing on this and this. And this right here, these two tell me, since there's no square root or anything, this is going to be the arc tangent. And I will use that formula. So in this case, a is 3, and u is going to be 2x, so that means du will be 2 dx. So you'll have that extra 2 on the outside. So because du over 2 is my dx. So now I end up with the integral of, we'll keep the 8 on the outside over here, 1 over, this will be 3 squared plus the u squared, and this will be du over 2. So bringing this out, I'll end up with 4. I'm going to finish it down here. Because the 2, I'm bringing it out, 8 divided by 2, and then this is the formula for the arc tangent. And remember, the arc tangent is going to be 1 over a arc tangent of, this will be u over a plus c. So this is 4 times 1 over 3, the arc tangent of u, which is 2x, over a, which is 3, plus c, and I could just say this is 4/3 arctan 2x over 3 plus c. Okay, moving on to that next one over here, and now we've got an e to the x. So over here, you can kind of do this with guess and check, because if I guess e to the 3x plus 2, and I take the derivative of this, I would end up with e to the 3x plus 2 times 3. Is that what I want right here? Close. I just don't want that 3 right here, so I need a 1/3 out in front of it, and e to the 3x plus 2 plus your c. If you didn't want to do guess and check, you can always let u equal the 3x plus 2 and do substitution on this. So du equals 3 dx. So du over 3 is your dx. And then this would just give you the integral of e to the u, du over 3, and then you end up with the same answer. All right, let's take a look at what we have next. We are on number 10. We've only got a couple more on this page, and then we'll move on to the next page. So for number 10, this is just our integral of a to the x dx, which is simply going to be a to the x over ln a plus your c. So in this case, it's just a 4, so this integral is pretty straightforward. This will be 4 to the x over ln 4 plus c. All right, on to that next one, which we have this integral of e to the x, and let's see what we could do with this. Let's go ahead and do substitution rule on this. So I'm going to let u equal my 1 plus e to the negative x. That's the substitution rule I have chosen to do on this one. So that means du will be e to the negative x times negative 1 dx. So let's make this substitution, and I will end up with the integral of u on the bottom here, and on the top I'm just going to leave this like this. If I solve for the dx, this is du over e to the negative x, like this with a negative 1. That's my dx. So I'll just leave this as e to the negative x times this du over negative e to the negative x. So those will reduce out, and I'll just have a negative out in front. So negative integral du over u, and this is just negative. The integral of du over u is ln absolute value of u, so plus the c. So substituting this back in, I get negative ln absolute value of 1 plus e to the negative x plus c. There we go. And taking a look at this last one that we have here, we have to find the inverse derivative of a for f of x at a equals 6. So that means I have to use my inverse derivative formula, which is the inverse derivative of a is 1 over the derivative of the inverse of a. And so that means I need a couple things. I need the derivative of x here at the a value eventually, which will be 3x squared. And then this is x to the negative 1, so it'll end up being plus 4x to the negative 2. I also need my inverse. So the inverse of this is going to be x equals y cubed minus 4 over y. So since a is 6, to get the inverse, I need to know when 6 equals y cubed minus 4 over y. And this is one of those problems now where I got to think about it and say, okay, if I don't have a calculator, how can I solve this? If you have a calculator, you graph it and you look for the intercepts. If you don't have a calculator, it's going to be something that stands out. So I choose values such as I guess 1. If I guess 1, well, I'll get 1 minus 4 over 1. That is not 6. So how about we guess 2? 2 gives me 6 equals 2 cubed minus 4 over 2. This is 8 minus 2, so 6 equals 6. So this was a good guess. So that means y is 2. So that's the value of my inverse. So this tells me that in this formula, and now I'm looking for the derivative at 2, because that was my inverse. So I come back over here and I plug in this 2, and I'll get 3 times 2 squared plus 4 over 2 squared, and this will give me 4 times 3 is 12 plus 1, which will be 13. So this is my f prime of 2, which I'm plugging in right back over here. So this becomes 1 over 13 is my inverse derivative. All right, now we've got our next batch of derivatives here. So y prime will be, natural log is 1 over this, so it'll be 1 over x to the 5th times cosine squared x. Now I need to chain rule it. So in this chain rule, I have to take a product rule. So first times the derivative of the second, which would be 2 cosine x times negative sine x plus the second, which is cosine squared x, times the derivative of the first, which is 5x to the 4th. That's a lot of writing in there. So now let's just see what we can clean up out of this. So y prime will be, let's see if I could take out something. I can take out an x to the 4th, and I can take out a cosine of x, and I'll be left with 2x times this negative sine x, and then plus the 5 and the cosine x, all over this x to the 5th cosine squared x. So I end up with y prime equaling 4 of these with that, this cosine with one of those, and then I'll end up with negative 2x sine x on top plus the 5 cosine x all over. I've got 1x left down here, and I've got a cosine x left down here. All right, moving on to the second problem. Right here, let's draw this line so we can determine what's going on. Over here, y prime will be, now I need a quotient rule. So this is going to be bottom times the derivative of the top, which is going to be 1 over x, minus the top times the derivative of the bottom, which will just be 1 over this bottom, 2 plus x, quantity squared. So y prime will end up being 1 over x times this 2 plus x minus the ln x. There's really not much you could simplify with this, so we're just going to leave it like this. There's really not much you could do to simplify this. You could play around a little bit, but I'm just going to go ahead and leave it like this. And now on this next one, for number 16, we've got e to the x, so f prime of x will be e to this, so 3x to the 7th minus 4x squared times the chain rule of this thing, which will be 21x to the 6th minus 8x. So just a matter of writing this out. So f prime of x will be this 21x to the 6th minus 8x times e to the 3x to the 7th minus 4x squared. There's really no simplifying on that one. So moving on, let's take a look at these next set of problems. Now we're back to integrating. And on this one, it says integral of tangent 2x dx. Okay, so let's go ahead and let u equal the 2x minus 3, which means du equals 2 dx. Now, some of you can recognize this through guess and check that it's going to be the integral of tangent formula. So if you want to do it through guess and check and automatically assume that it's the natural log of the absolute value of the secant of u, meaning this is our u, go ahead. Otherwise, we have this as the integral of tangent u, and this will just be du over 2 when I substitute that in. So I'll get 1/2 the integral of tangent u du, and we've memorized this one, which is the natural log of the absolute value of the secant of u plus c, and then we have our 1/2 here. So again, you need to memorize the integral of the tangent. So now substituting this back in, we get ln, absolute value of secant, and then this is going to be 2x minus 3 here, plus rc. All right, moving on to the next one. Over here, we have the integral of 3x squared over x cubed minus 4. So let's do this through, again, some of you may recognize it again, just through guess and check, and you know you have to guess the ln of x cubed minus 4, and then just kind of play around with it from there. If you haven't seen that, let's go ahead and let u, we'll do substitution, equal the x cubed minus 4. So du equals 3x squared dx. So du over 3x squared equals my dx. So now I got the integral of 3x squared over u and my du over 3x squared. So these conveniently reduce out, and I get the integral of 1 over u du. So this is ln absolute value of u plus c, which is ln of x cubed minus 4 plus c when I substitute that back in. All right, taking a look at this next one, I have an x on the bottom, 3 sine ln x on the top. So let's go ahead and go to our substitution rule. We're going to let u equal ln x. I'm picking just that one for this problem, and you'll see why in a minute. And du will be 1 over x dx. So substituting this in, I'll have the integral of 3 sine of u, and that's why I did that. And then this will be over x, and over here I have x du when I solve this right there. So these conveniently reduce out. So now I just have 3 times the integral of sine u du, which is going to be negative 3 cosine u plus c, and negative 3 cosine of the natural log of x plus c is our answer. All right, taking a look at the next batch. Let's slide this up. And here we're looking at the integral of cosine over 2 minus sine x. So let's let u equal this 2 minus sine x. Du will end up being negative cosine x dx, which gives me du over negative cosine x as being my dx. And let's make our substitutions. So here I'll just have cosine x on the top. This bottom became the u, and then this became du over negative cosine x. Again, conveniently those go away. I have negative the integral of du over u, which is 1 over u du, which comes out to be negative ln absolute value of u plus c. So negative ln absolute value of 2 minus sine x plus c. All right, next one is the integral of a to the x. So we should know these already. The integral of a to the x dx, that's an integral, looks terrible, is just going to be a to the x over ln a. Obviously, if there's any chain rules involved, we have to take those into account. In this case, we'll get 4 to the 3x over 3 ln 4 plus c. Why the 3? Because remember when we took the chain rule over here, the du, if you let u equal to 3x, du would be 3 dx, and so you need to put the 1/3 out in front to get rid of that. Okay, now moving on to this next one. Let's go ahead and we will let u, in this case, be our ln x. So du equals 1 over x dx. So now I end up with x du equals dx. Let's put this stuff in. I'll get the integral from 1 to e. And over here, I'll have the root of u, just like that, over x, and then this will be x du. These conveniently reduce out. I'll get the integral of, from 1 to e, of root u du, which becomes, let's go ahead, I'm going to do something different. So before I integrate, I want to change these bounds. So let u of e, it'll be easier if I just leave it in this instead of resubstituting to integrate than resubstitute. I'm going to do it this way. So u of e equals ln of e, which is 1. And then u of 1, again, I'm choosing to do this. This would be ln of 1, which is 0. So I'm changing the bounds to be from 0 to 1 of root u du. And then in the end, I won't have to resubstitute. If you don't do that, you can resubstitute in the end. But I just don't want to because I don't want to have to take natural logs. I'll just do it this way. So this is u to the 1/2. So I'll get u to the 3/2. And I'll need a 2/3 out in front on the bounds from 0 to 1. So this becomes, plug it in, you get 2/3 minus 0, which is just 2/3. Done. And let's take a look at this next one over here. Again, we have an inverse derivative problem. So our inverse derivative formula that we've memorized by now of a is equal to 1 over f prime of the inverse of a, like that. So it means I need a derivative. And finding a derivative here, this is a root, so this will be 1/2 of this stuff, so 2x cubed plus x squared minus x plus 2 to the negative 1/2 times 6x squared plus 2x minus 1. So if I need that, and then I also need the inverse. So the inverse is x is going to equal this 2y cubed plus y squared minus y plus 2. And I'm looking at a equals 2. So that means 2 equals this square root. So I will go ahead and say 4. I'm going to get rid of the square root equals 2y cubed plus the y squared minus y plus 2. And again, since you don't have a calculator, you just kind of have to look at it and guess some values. If I guess 0, If I guess y equals 0, plug it in, doesn't work. So let's guess y equals 1. I plug it in. I get 1, so that's 2. So right here, let me show you what I'm looking at. I get 2 plus the 1 is 3, minus the 1 is 2, plus another 2 is 4. So y equals 1 is the solution for this. So y equals 1 is what works. All right, so that means since I have the inverse, that means I need the inverse of 2, which gives me 1. So I found the inverse right here. The inverse of 2 gave me 1, which we just did right on this side. So now I need 1 over f prime of 1. Well, I have f prime right there, so that means f prime of 1 comes out to be 1/2 times 4 to the negative 1/2 times this over here comes out to be 7, which gives me 1/4 times my 7, which is 7 over 4. Okay, so that becomes 1 over 7 over 4, which gives me 4/7 as my inverse derivative. And now we are on our last page here. We just have a few more questions. So here it's asking for the inverse of 9. So I simply switch out the x and y's. I get y squared plus 2y plus 1. And I need the inverse of 9, so that means 9 will equal this y squared plus 2y plus 1. And there's a couple different ways you can solve this. You could bring the 9 over, or if you see this, actually this is probably better. If you see this like this becomes y plus 1 quantity squared equals 9. So plus or minus 3 is going to be y plus 1. So you get two answers, y equals 2 and y equals negative 4. Again, if you wanted to bring the 9 over and say 0 equals y squared plus 2y plus 1 and solve it this way, you could have done it that way. I'm sorry, this would be minus 8 right here. And then you would end up with y plus 4, y minus 2. So you end up with the same answers. Let's just check that both of these work, h of 2 and h of negative 4. When I plug in 2, I'm going to get 4 plus 4 plus 1, which is 9. And when I plug in negative 4, I'll get 16 minus 8 plus 1 equals 9. I just wanted to check my work here. So the two answers are y equals 2 and y equals negative 4. All right, moving on to the next one over here. If f of x equals that, find the derivative. All right, simple derivative question. So f prime of x equals, well, I'm going to go ahead and use the quotient rule here. So this becomes ln x, so the bottom times the derivative of the top, minus the top times the derivative of the bottom, 1 over x, over the bottom over here, ln x squared, which gives me ln x minus 1 over ln x squared, and I need to find it at e cubed, so this becomes ln of e cubed minus 1 over ln of e cubed squared. Now this, since it's ln, is just going to come out in front, and then the ln of e goes away, so this is just going to be 3 minus 1. Over here, same thing. This just goes away and you get a 3, so this becomes 3 squared, so you end up with 2 over 3 squared, which is 9. And finally, we have our last question here. Find the equation of the tangent line to the curve at the given point. So we need the slope, which is y prime, and in this case, I will take this derivative. That's 1 over e to the x minus x cubed, and I need to chain rule that, so that's e to the x minus 3x squared. And now I need this at x equals 0. So let's plug it in. Y prime will be 1 over e to the 0 minus 0 cubed times e to the 0 minus 3 times 0 squared. Well, this comes out to be 1. That's 0. This is 1. That's 0. So I end up with 1 over 1. So my slope is 1. And now I need to find the point. So y minus y1 equals mx minus x1. I have this, and I need to find my point. When x is 0, what's y going to be? Well, let's plug it in. Y equals ln of e to the 0 minus 0 cubed. Well, this just ends up being ln of 1, which is 0. All right, so I plug these in, y 0 here, 1 there, 0 there. I just end up simply with y equals x as my tangent line. So, thanks for watching. Lot to do here in this video, a lot to study for. Hit that like and subscribe button, and I'll see you guys in the next video.